people. Today we'll be looking at geotechnology tool, and we'll be looking at withering. So let's look at the definition of withering. Withering can be defined as the disintegration, breakdown of rock materials. Let's now look at types of withering. Types of withering. One, there is this we call mechanical withering. In mechanical withering, there is no change in chemical composition. It's just disintegration into smaller pieces. You can see the process here. It has started with one large rock. It has disintegrated to smaller parts of the rock, again to smaller parts, and to the smallest parts of the rock. Let's now look at chemical withering. Chemical withering can define this is the breakdown of rocks as a result of chemical reactions. Let's look at a sample of chemical reaction. You can see this calcium carbonate rock. It reacts with carbon dioxide plus water, and it results into calcium ions and these hydrogen carbonate ions. Yes. That's was an example of chemical withering and a reaction example of it. Now let's look at mechanical withering. This involves physical breakup of rocks by different methods, which include pressure release to this water, which is freeze those cycles. Number 3 is crystallization of salts in cracks. Number 4 is thermal expansions and contractions. All this increases the total surface area exposed to withering processes. Let's now first look at the first example of mechanical withering, which is exfoliation. In exfoliations, rock breaks apart in layers that are parallel to the Earth's surface. As the rock is uncovered, it expands due to lower confining pressures resulting to exfoliation. Exfoliation really depends on consistent heating and cooling of the rock. Here is a diagram of an example of exfoliation. You can see here the rocks are withered. You can see how it reacts. It is heated, deep Pluton, expansion and sheeting. It expands and contracting, and it results to exfoliation withering. Let's now look at frost action or frost wedging. This is where the rock breakdown is caused by expansions of ice in cracks and joints. Thermal expansions due to the extreme range of temperatures can shatter rocks in desert environments. Repeated swelling and shrinking of materials with different expansion rates will also shatter rocks. Here is the examples of what we are calling the frost. Actually, you can see it happens in somewhere there is ice. You can see in the background there is ice. Is another example of frost wedging. And let's now look at roles of physical withering. 1. It reduces rock material to smaller fragments that are easier to transport. Number 2. Increases the exposed surface area of rock, making it more vulnerable to further physical and chemical withering. Let's now look at chemical withering. Chemical withering. Chemical withering, this is the transformation slash decomposition of one mineral into another. Water is the main operator and it helps in reaction process. These operations may involve one is dissolution. Many ionic and organic compounds dissolve in water like silica, is potassium, is nitrate, magnesium, calcium, chloride, is calcium carbon and sulfate ions. Acid reaction, this involves water, i.e. involves water plus carbon dioxide to form carbonic acid, which it helps in withering. Then there is water plus sulfur, which results into forming sulfuric acid. It also helps in withering of the rocks. Also, hydrogen ions are effective at breaking down minerals. Then oxidation, this is oxidation. Oxygen dissolved in water promotes oxidation of sulfides, ferrous oxide, and native metals. There's this organic activity, plant material, helps makes hydrogen ions available. Then there is hydration. What is hydration? Hydration is attachment of water molecules to crystalline structures of a rock, causing expansions and weaknesses. Then there is this we call hydrolysis. Hydrolysis is a combination of hydrogen and oxygen in water with rock to form new substances. Then there is what we call solution. This is a process by which rock is dissolved in water. It is strongly influenced by the pH and temperature. When water becomes saturated, chemicals may precipitate out, forming evaporate deposits. Calcium carbonate is silicate limestone, sodium chloride, salt, and calcium sulfate gypsum are particularly vulnerable to solution withering. Let's now look at what we call biological withering. Biological withering can be both chemical and mechanical in nature. It includes the following activities. One is root, split rocks apart. Roots produce acids, dissolves rocks. Tree, the rock, and there is also what we have burrowing animals, burrowing like moles. As we have come to the end of the session, and thank you for your time.